Alright everybody, welcome back to another update, and we are finally back. And we were away for some duration, so we were unable to do the high risk and moderate risk outlooks, but this will be a short, concise and clear update on the forthcoming event, so the severe weather SPC outlook. So today there is a new outlook of what has been designated an enhanced risk from the Storm Prediction Center over central and northern Illinois, going up towards the Chicago region, and then expanding outwards as the main initiation of that storm complex will translate over to the eastern side towards the Ohio Valley in Indiana, part of Michigan and western Ohio with a slight risk. And so we do have a categorized 10% tornado risk, so this has been rapidly increased from a marginal risk now to an enhanced risk with a 10% SIG TOR, and that's been recognized through the CAM models, or the convection allowing models, that have high precision, high resolution data that is deterministic of what what the convective mode is and how the storm pattern will evolve, and they show a supercellular arc. So along the low pressure system, along the eastward pushing dry line / cold front, there will be an arc of potential supercells within this 10% SIG TOR region. So 25 miles of any given point within this 10% hatch is where significant strong tornadoes can occur, and that strong tornado potential is very defined in that CAM model. We've got a general broad risk of wind and hail as well, but this is now very tornado driven. With a quick overview from the SPC's words, there is deep 989. I cannot speak at the moment. A cyclone near the northeast Kansas, northwest Missouri border, moves northwestwards to northern Illinois and lower Michigan overnight, in conjunction with a deep mid-level trough of 100 plus knots mid-level jet streak. And there is some elevated convection that could tamper with the instability, but there is some large hail threat currently, and there should be surface heating within the cloud breaks, continued moisture advection, relatively cool mid-level temperatures all contribute to a warm sector destabilization, so within the warm sector. And then we're talking about MLK values here, so instability values as well. And then we've got some surface-based thunderstorm development now, mentioned rather than high elevated based, which would be more hail threat and less of a tornado risk, with stronger downdrafts fostering strong winds and less of a tornado risk in the previous demonstrated outlooks. And there will be deeper buoyancy profiles will be on the cyclonic side of the mid-level jet, where 500 millibar temperatures will be less than negative 20 degrees Celsius, so we're talking about a cold core setup. And there is some mention of large hail, but no hatched risk. Alright, so now looking from the large scale pattern. So with this pattern, we will observe that from within 12Z to 0Z, essentially, you see what essentially produced the Friday outbreak. So the Friday outbreak had this sort of almost like a ramp, but it's called colloquially, it's called like a ski jump trough. So just because of the shape of it, this sort of ramp structure of this trough is just very easily defined as a ski jump trough, where essentially you've got this strong negatively tilted strong jet max near towards the eastern part of the trough in the right exit region, and the left exit region, and that's where the significant diffluence occurs within this tight compact low, and the surface low will be close to the upper level low, producing a cold core setup. And this evolution is what's being seen here, and it will persist. And this Friday outbreak was very significant, so the same threat is now going to occur in this region, and it's quite fast progressive. At least by 18Z, it seems like the main risks should start to continue, and then 21Z should really persist as well. So yeah, with 18Z being really favourable, in that enhanced risk region, and then kind of pushing eastward, and 0Z pushing to the higher value. So it broadens out slightly, but then initially remains compact. Alright, now looking at 850 millibars on the same duration, we're looking towards 18Z and 21Z. So 18Z, we're going to look at it because it really overlaps with where the 500 millibar flow suggests storms could initiate around the time of the progression, the trough, quite a fast progression. And one of the things to mention was the upper level, using Chris Broyle's method, the translation of this jetmax from where it is currently to 18Z. You can see how fast it actually moves across, and this is a very favourable pattern recognised to overlap with significant tornado outbreaks, or just significant tornado potential with significant tornadoes within that larger storm complex. So this could be a favourable pattern to produce that tornado risk, and it could demonstrate that hatched risk that has been overlapped. And then we're looking at the 850 miles, so the near surface, the low level jet is essentially what is called at the 850 millibar level. We're looking from the 12Z to 18Z and 21Z progression. By the time we look at 18Z, we're looking into the central Illinois, looking at 40, 45, even 50 knots within this region. Slightly less as it gets up here. That's more towards the low, and that where as it progresses in that upper quadrant where it's not as strong, but where it is strong is along this southern flank, where you get this backed flow, the southerlies, and then atop you get some southwesterlies to westerly direction. That produces this hodograph-like curvature, which we'll see. It's like a C shape due to the changing winds, the varying of those winds and strengthening of those winds with the height, because you've got these weaker winds at the surface with much stronger winds aloft, with, as previously mentioned by the SPC, upwards of 100 plus knots in the jetmax, so where the winds are the strongest. So you can clearly see where the warm sector is defining the cold front, and this dry line is very favourable backward C shape. So essentially you've got the triple point in this region, and you've got a very advanced north-south oriented dry line where the initiation of storms will be very favourable for supercellular convection, particularly along the central Illinois region, and some into the open warm sector should there be any sort of method of initiating convection into the open warm sector itself. But you see this strengthening low, and you've got very tight isobars on the backside. This should contribute to some sort of blizzard conditions on the backside, and potentially more hazardous wildfire/dust conditions in the south. But a very strong surface low, and the surface vorticity along these boundaries and along the triple point, essentially because it's right next to the potential supercellular arc, it will provide its cold core setup and much more surface convergence and vorticity along the surface low itself, and so that will be a place to observe from a ground standpoint, being at that location. The dew points will not be as elevated, but as demonstrated by the Friday outbreak, you only need 55 dew points to produce a significant setup. So even by 18Z, we're looking at significant progression of 55 dew points at least into this region, and that is all you need. Right, and now we're going to look at soundings within probably 18 to 21Z, where the main SPC outlook is highlighted. So 18Z, probably looking at storm initiation here. You've got these red lines, and this is where the most unstable is essentially, so where the actual significant storms will be forming within, and talking relatively stable air mass here, and you won't see any sort of bubbling cumulus in that region, because the storms will initiate in this region, where the instability will build within this region with the richest moisture here. So this is where you'd look. And initially, to be honest, I think the shear is not as. I think we should take another sounding here. So probably looking somewhere maybe up into the surface, up here and down here for 18Z at least first. So it looks like the shear will be slightly delayed, as in the wind shear will not be provided until the progression of the trough much later. But despite the low level shear, and this shear is going to be modified, so this value is not necessarily demonstrative. As seen in Winterset, Iowa, the 2022, I believe, occurred, that tornado in a March outbreak as well, in a very similar environment, in a similar region. The localized convergence and terrain overlapped with the surface low vorticity and the cold core nature really amplified the setup, particularly from a kinematic profile, where this value could be almost double or even triple its value, just because it's modified sounding, and so this may not necessarily suggest what is going to be outputted. And we do have about 25, we have 15 to 20 knots, so relatively small supercells, as demonstrated, at least from this particular sounding as well. One of the other things that I've been looking at is, for research, is that looking at the streamwise vorticity currents, and so you have this sort of curvature where you'd look at the storm relative inflow, and then you'd put a perpendicular vector to the west of this line, and then if the line, well, you put a perpendicular vector to the lowest 0 to 3 kilometer part of the holograph, the purple part, and then you put a perpendicular line here, and then if this is nearly parallel to the storm relative inflow, then it's talking large amounts of streamwise vorticity currents, and the units and the values of are typically in the 0 point something value, so they seem very small, but that's actually just the way the units are demonstrated. And so when you have a value of 0.04, for example, that's usually trended in high significant tornado outbreaks where you get significant tornadoes, and so you would normally see a graph of the streamwise vorticity currents in the 0 to 2 kilometers at least, and that's where the most significant streamwise vorticity current is. And with this being very parallel, you'd have at least 80 to 100% streamwiseness of the vorticity currents, and that's just extremely efficient at consummating tornadogenesis when other parts of the profile are at least favourable. And so with a modified wind shear profile with that streamwise vorticity current combined with this thermodynamic profile, so we're talking at least definitely over 1,000 joules per kilogram, because this is on the conservative side, as well as not necessarily accounting for the dew point temperature spread, so increased surface heating and richer moisture could be advected because of strong southerly backflow with a deepening low pressure, as we saw. And this also may not necessarily account with as steep of elapse rates, it's still showing at least 7 kilometers within 36 kilometers, and then but then we look at the surface 3 kilometers, we're talking very high values, almost 9 degrees Celsius per kilometer, so very steep lap rates due to that cold core setup. But again, these could be underdone as well due to the temperature values and having now having a bias on the temperature values. So again, it would be colder temperatures aloft, which would mean even steeper lapse rates. And one of the other things that you'd look sometimes even is not necessarily here, but the wet bulb zero value. So that's essentially that's when the air parcel kind of evaporates by adiabatic cooling at a certain temperature, and that is normally looking around, well, at least in this profile, it's looking around 800 millibars, and that will be significant because you've got some deep moisture with it up here, and that's a relatively low wet bulb zero. So what that means, essentially, what that correlates back to in a more significant sense, is you'd have these significant RFDs or these mesoscale type of systems on the backside that consummates tornadogenesis, and that essentially under larger, more broader simpler terms, is that it'll help allow volcanogenesis to occur much more significantly. And one of the last things to talk about here is 3K, which is at around 181 joules per kilogram, which is a very significant percentage of the total mixed layer cape, or even the SFC values. But that is going to be, again, potentially higher, and this is one particular region. So again, this is very significant for a cold core setup, and I do think that it will be demonstrative of how the Friday setup went off and produced, and we will be doing updates on that significant event with each tornado one by one in a separate video discussing the outbreak, and that will be done in a future video. So last thing to talk about is, well, of course, there's the sounding as well. This sounding is probably not the best to talk about because of the partial contamination, and not necessarily, and suggesting some sort of unusual substance of dry air within the 700 millibar region, causing this weird, almost sort of warm nose within the profile. But looking at 21Z, just quickly look out here. Probably best just to take two quick sounding and just have a glance at it as well, and then we look at the cams as well. So again, this saturation is a bit overdone, and there's some feedback here, so that's not necessarily going to demonstrate what's going on. And a very similar profile, it persists for a significant period of time, and we've got enhanced low level shear in this profile, so much more, and a modified version of this profile will definitely be very favourable for significant tornadoes. And again, overall favourable profile, and ignore this part here that is oversaturated. And also, one of the things actually just to look at here, for example, is you can see around this part of the, so around just below 300 millibars, you can see that the temperature is going towards -30, so very cold, even -10. So we're even getting freezing temperatures at around 650 millibars potentially, and that's very cold aloft, and very cold core demonstrated because of this cold steep lapse rates even in the mid levels, rather than just being in just the upper levels. As obviously, as you rise in the mid troposphere, you get the profile, or a super adiabatic profile, where you can see the temperatures cool very quickly in the upper levels. Last thing is just the HRRR. Don't take these necessarily as the absolute demonstration of what will happen, but rather an idea of the evolution. So we got these storm complexes. Again, any of these could be significant. This HRRR run is just a suggestion. It's not really going to be an absolute outcome of what's going on. So you've got some significant storms here in the northern quadrant, but you've got this sort of isolated supercellular convection coming through this region, and it persists for a significant period of time actually, and particularly so around 19Z it initiates, 21Z it really gets its act together, and between 21Z and 23Z is the most significant period of time to watch. So I think that is the best way to end this video, with overall thought of what this potential would be. And so again, this hard enhanced risk is what we have today. And with that, I will see you guys in the next update.